Okay, this is the fall 2014 AP Calculus prep session. This is part 3 of the problems relating F prime, and F double prime. And this is in the free response portion of the prep session. And this is a calculator required problem. And so the calculator, I don't know, it says required, actually calculators are permitted. And so we're going to look at some screenshots of calculators on this. For t is greater than 0 and less than 31, the rate of change of the number of mosquitoes on Tropical Island at time t days, so here we have 31-day month, I guess, is modeled by r of t equals 5 times the square root of t times cosine of t over 5 mosquitoes per day. There are 1,000 mosquitoes on Tropical Island at time equals t equals 0, okay? And so A shows that the number of mosquitoes is increasing at time t equals 6, and B at time t equals 6, the number of mosquitoes increasing at an increasing rate, or is the number of mosquitoes increasing at a decreasing rate? Give a reason for your answer. What we're looking for is to find out where we are in the continuum between the whole, we looked at earlier in part 1, the whole level 1, level 2, level 3. Okay, level 1 is going to be our amount. Okay, in this case, in the context of the problem, how the number of mosquitoes. But what we're given is we're given a rate of change formula. So this formula here is rate of change. So this is going to be our starting point. We're starting with the rate of change equation. And to find if the number of mosquitoes is increasing, all we need to do is plug in the time 6 into this function here, and here we have t over here, instead of that cosine, then we have t over here, square root of t, and if this value, when we plug in 6, is positive, then we've shown that the number of mosquitoes is increasing. Let's go to the calculator and look at the screenshots we have, and what we're going to do is we're going to store a value of 6 to x for t. And so to do that, we're going to first press the storage key, STO, which is just above the on key. So here's the storage key. We press storage, so press STO. Then we're going to, actually before that, we're going to press 6. Enter 6. Let me rewrite this here. I'm going to mess this up. Press 6. So enter 6. Press STO for storage. So first we press 6, then STO. Then press X. Then we enter. Then enter. So here's the X key, and here's enter. So we have all these 4 keystrokes here. 6, storage, X, enter. So the value of 6 is stored for X. Next, we have this function. We're going to enter 5 in our calculator, just like this. 5 square root of x cosine, make sure our calculator is in radians, x over 5. So we just entered this function, and we already have this function entered takes into account replacing this x with 6. And then we press enter, and we get this value here. 4.4379, etc. And what we can do is we can, with this answer A, and so this will be our answer to A, and I'm going to write it up here. Answer to A since 4.4379 is greater than 0, then number of mosquitoes is increasing. Number of mosquitoes is increasing. Is increasing. So we've shown that. Okay, so that's how we show this. This number will give it away. Next, we look at part B, and we're going to find the derivative at a point. And the keystrokes for that are we're going to press this math key. Let's see if the next screenshot is here. Let me put that. We press math, then option 8, which is derivative at a point. Math, then option 8, and I think you get options 1 through 9, and 8 is derivative at a point. And then we're going to see this set up here. And next, we're going to put our function right here, replacing t with x, and then at the right we put x equals 6. So instead of finding the value of the function, this will be like the derivative of the rate of change, which is going to be like the second derivative. And so if this number is positive, then these would be increasing at an increasing rate, or if negative, increasing at a decreasing rate. And we press enter, we get negative. Okay, since, we explain this, since the derivative, okay, derivative of r of t is less than 0, is, well, you want to put in the number that we calculated too, is negative 1.913, which is less than 0, dot, 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 therefore, mosquitoes increasing at decreasing rate. They left out the parts C and D, and parts C and D have to do with what is the greatest number of mosquitoes that exist over this period and when did that happen. You see that what we'd have to do is go up and integrate this function essentially to get that, but we're not going to worry about that. Okay. And anyway, another thing we can do is we can graph this function by putting the function right into the calculator, and we see a relative maximum, and we can find the relative maximum by going to second trace and to, let's see, we're finding the slope. Okay, second trace, and then we go and see x equals 5.95. If we go to dy dx and press that, we get we'll press it again, we get a slope of negative 1.888, which is negative. That's not exactly on 6. To get exactly 6, we need to set a friendly window. If you go to window view and set it instead from negative 10 to positive 10, x min to x max, the calculator has 94 pixels left to right, and so we can match up the number of pixels with the keystrokes by setting the Xmin and Xmax at negative 9.4 and 9.4 respectively. And we go back and we can enter exactly 6, and we can go to second trace 6, and we get negative 1.91, which is what we got earlier. Anyway, that's answers A and B. And so again, the whole process of finding which level we're at and going to which would be in this case rate of change, and part A is just simply using that number and plugging in. Part B is looking at the first derivative of that at a t equals 6. So I hope this has been helpful to you, and I thank you for viewing.